Hello, I'm Leon, and today we are gonna swing the compass. This is my new Cassens&Plath compass, and especially made for me with the white compass rods, important to better read the shadow for celestial navigation and doing the compass check, which is necessary for the RWA Yachtmaster Ocean exam, for instance, but also very good to check your compass in case of a lightning strike where the GPS and other electronics might not work. So today we're going to swing the compass. So this is a new compass. So first of all, we have to align it to the ship's direction. So I have looked through the compass from behind and seen that the middle needle and the steering needle is in line with the mast in the front. And then I have made marks here so I can find the position again, because I haven't attached the compass as yet, because we have to adjust it. And we adjust it in two steps. One is first time, once in a lifetime, so to speak, that we do it in a rough way. And for that sake, to compensate for the deviation on board, this compass has a little feature that I have ordered. And these are these metal pieces here and some screws on the side. So with these screws, I can turn these a little bit to change the metal position of these, and by this align it. So we will have a northerly course, and then we do one of these axes, namely the one that is perpendicular to the ship's direction. Then we go to the easterly course, and then we will do the one that is aligned with the heading. Then on the southerly course, and if it is not perfect, we can turn back just half of the error, and then on the western heading, and then we can adjust it again back half to what we did on the eastern one. We will do that in real life. And when we have done that, we can put it back, and then we have to do the deviation table. But the good thing is the second step, the deviation table, which you should do every second year, that is only to amend the little differences. Most part the magnets will have done. On this boat, I'm very lucky because I have a satellite compass. So the heading will be shown in magnetic direction. That's how I have set it. So it's a matter of very easy to just compare what the satellite compass says compared to what my compass reads. And this difference, since the satellite compass is set to magnetic headings, is then the deviation. So making the deviation table is rather easy if you have a satellite compass. My satellite compass is a Furuno SC33, but there are also smaller ones, but not so many other brands for this kind of yachts. But it's very advisable to have one because you can, first of all, have very accurate readings. It's very fast when it comes to heading, which is necessary for radar navigation and getting proper RPAR target readings. But that's another thing. I also have here a special non-magnetic screwdriver with which I can amend the screws a little bit. So what we'll do now, we'll drive out and drive the circuit. So follow me on that. So we're now having 0 degrees on our course there on our heading, more or less. And then we compare it with this one. So this is 1 degree there, and we can read there that it is a bit too much actually. So what I will be doing now is to lift this compass, and I will just turn this screw a little bit clockwise because it showed a little bit too much. And then I put it back again, and then we can compare again. 1 degree there, and see what it shows there. And what does it show? Oh, 1 degree. So 0 degrees, 0 degrees. So it's exactly perfect. So that's perfect. So now we have adjusted the compass for north. Now we turn 90 degrees towards east and do the same thing there with the second screw in line with the ship's heading. So now we've turned 90 degrees towards east, and on the satellite compass it shows exactly 90 degrees. So that's great. So let's compare it with the compass. Oh, it shows some 100 and 12 degrees something. So we have to change that. So I take my little screwdriver here and I lift it up and I turn just slightly on this button here on this screw here, which goes in the direction of the boat. Just turn it just slightly. So let's see what that is. So align it again towards the marks here, which I made in the holes, so it the compass shows in the ship's direction. And now we can see, are we lucky? We were lucky. It was actually 90 degrees. That's perfect. I mean, we couldn't be better. So let's go south and have a look there. So now we've turned to southerly course and we can see that it's about 170 degrees. So now it's, on north it was perfect, and on south it's now 10 degrees too little. So we can't go on 180 degrees here, because then on the north it's wrong again. So that's why we have to just turn 5 degrees. So from 170 it should go 175. So that's why I take again my little screwdriver and take the one that is perpendicular to the heading and turn it just so slightly here. It's really difficult, just a little bit. And then we put it back, aligned to the ship's direction, where I've made my marks through the holes, and we'll read it off. And what does it say? Then let's go west and see what happens now. So now we've done a couple of turns, always turning 90 degrees, north, east, south, west, north, east, south, west, and trim the little screws. And my tip is just turn just so slightly, a degree or something on the screws to adjust it. And now actually all the figures are showing a little bit too little on the compass compared to the satellite compass, but always almost the same amount. That means that either the satellite compass is not completely aligned to the boat, I'm talking about 2-3 degrees, or the compass is not completely aligned. So we have to check that in the harbor, in the marina, so they are both pointing exactly towards the bow. So that's point number one. So we've done that. So I'm pretty happy with these little magnets. What we now need to do is to do the deviation table, and that is easily done. That we go steer a course with the autopilot, and then we click on the autopilot every 10 degrees to starboard, and on each course every 10 degrees we compare what the satellite compass reads and the compass reads. And it's not so exact that you are exactly on 10 degrees, then 20, then 30. It could be 11, 21, 31, and so on. At least you know in which direction the differences are between the compass and the satellite compass. So that's what we're going to do now. So we've now done a whole 360 degrees and turned every 10 degrees and compared the satellite compass with my new Cassens&Plath compass. And I must say, I've never had such a beautiful deviation table. Look at this. The maximum from maximum positive to maximum negative, meaning from maximum east to maximum west, is only 3 degrees. So I have -3 degrees here on 120 degrees heading and 0 on all the rest almost. So it's fantastic. So thanks to the small magnets, I have hardly any deviation at all. Now I don't have any positive ones, I only have negative ones. So that means that the alignment with the ship is not quite correct. I would say that it's about 1.5 degrees off. So either I have to turn the compass 1.5 degrees or the satellite compass, which I do electronically on my Furuno plotter here. So either or, in order to get them aligned with the ship. So this I will now use as my new deviation table with only a few degrees wrong, thanks to this fantastic compass. Thank you for listening.